Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 2 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3013. Divide an array into sub-arrays with minimum cost 2. So this is a hard level problem marked by LeetCode. Yesterday we solved part 1 of this problem number 3010. So this problem actually a little bit different. 3013, it's a little bit different. So let's read the problem statement first. So in this problem you are given a zero indexed array of integers nums of length n and two positive integers k and distance. So this is additional thing, these two. So yesterday size was fixed, three length sub arrays we need to find, but today we have two values given to us, k and distance in part 2. The cost of array is the value of its first element, so it's like part 1 only. For example, the cost of this is first element of this, right? 1 2 3 1, while the cost of this 3 4 1 is first element 3. Here we need to divide the nums into k disjoint contiguous subarrays such that the difference between the starting index of the second subarray and the starting index of the kth subarray should be less than or equal to the distance. In other words, if you divide nums into the subarrays like this, nums from 0 to I minus I1 minus 1, and then nums of I1 to I2 minus 1, and then nums of Ik minus 1 to n minus 1, then the starting point of this last subarray, the starting index of the kth subarray, the difference, right, with the starting index of the second subarray. So this is the second starting of the second subarray. So the difference between these two, Ik minus 1 minus of I1, it should be saying less than or equal to distance. So this line, we have to return the minimum possible sum of the cost of these subarrays, and these are the constants. N value is from 3 to 10 to the power 5. So definitely we can't solve this problem in n square quadratic time complexity this time, because with this we will get time limit exceed error. And nums of I value is from 1 to 10 to the power 9. Very huge value, right? So if I'm going to do the addition, so this value becomes very large. Okay, no issues. K is from 3 to n, and a distance is greater than equal to k minus 2 and less than equal to n minus 2. Okay, so now let's understand this with an example here. In this example number 1, if you see, k is equal to 3 and distance equal to 3. So k is equal to 3 means we need to find three subarrays. So let's say these three subarrays are this is one, this is one, and this is one. Let's say this is one, this is one, and this is one. Now cost is going to be, definitely cost is going to be, the starting of this is 1, the starting of this is 2, and the starting of this is 2, so cost is going to be 5. That is my output. Okay, and the one more check we need to do here. If I just give the indexing here 0 1 2 3 4 5, so starting of the kth subarray is 5, and if I subtract from it the starting of my second subarray, that is this index 2, so 5 minus 2 is less than equal to my distance. So yeah, it is true here. So I'm doing valid subarrays formation here. So the best possible way to divide nums into three subarrays is like this. This choice is valid because ik minus 1 minus I1 is 5 minus 2 is equal to 3, which is equal to the distance. The total cost is the starting point of all these subarrays, which is 5. So it can be shown that there is no possible way to divide nums into three subarrays at a cost lower than 5. So I hope that this example is clear what we are doing and how we are getting this output. Now let's understand with little bit a big example here I'm taking. So in this case, if you see, k I'm taking 5 and distance I'm taking 4, and in this case your output is 12. So first let me write it here 1, after that you have 2, then after that you have 3, then you have 2, then you have 6, then you have 4, then you have 9, then you have 2, then you have 8. This is what you have. Clear? Now here let me just give the indexing as well. So 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index, 8 index. Now here we have to find 5 subarrays. So for one subarray, the starting point is going to be, let's say, uh, this value. Okay, for next subarray the starting point is, let's say, this. For next subarray, let's say starting point is this. For next subarray, let's say starting point is this. For next subarray, let's say starting point is this. So this is nothing but a starting point of 5 subarrays, and we want the sum of all this to be minimized. This is what we need, minimized sum of all this. And one thing is fixed, just like in part 1. So first subarray is always going to start from here only. So this is fixed. So my I0 is fixed, it is going to be 1 always. My I0 is going to be 1 always. Now I need to find these values. Clear this part? This value is always fixed. We have to start from here. We can't miss any elements while forming the formation. So definitely the first subarray is going to start from here. But now I have to find the starting of second subarray, starting of third subarray, starting of fourth subarray, starting of fifth subarray. So one value I have found here. So now remaining values that I need to find is k minus 1. Total 4 values I need to find here. 1, 2, 3, 4. These 4 values I need to find. Now, okay, this is done. Now here, this is given to us, distance equal 4. So definitely there is some meaning of this variable. This is helpful for us. Okay, that's why it is given to us. So this is actually going to make our problem a little bit easy now. So let's say next time you are starting from here, the second subarray is starting from here. So the last subarray, can you start your last subarray from here? Tell me. So 5 minus 1, if you do, it is less than equal to your distance. So yes, 4 is less than equal to 4. So your second the last kth subarray can start from here. The kth subarray. This is my second subarray. This is my kth subarray. So we have to find the distance now. So in the problem it is given that I k minus 1 minus I1 is less than equal to distance, such that the difference between the starting index of second subarray and the starting index of the kth subarray, it should be less than or equal to distance. So this is given to us. Can my kth subarray will start from here? Tell me. So this is 6 and this is from 1. 6 minus 1. 5 is less than equal to 4? No. So it can't. So it can start from here. So just see this window now. Just see this window. This is one window, let's say. So here, from this window only, definitely your kth subarray can start from here. Your kth subarray can start from here as well. This is also possible. Your kth subarray can start from here also. This is also possible. But we need to find actually all these subarrays. So we have to do some adjustments as well. We can't directly fix kth. But I'm saying here, from here you can't find your kth subarray if your second subarray is starting from here. If your second subarray is starting from here, your kth subarray can never start from here. So now, if you see here, in this specific window, you will find the value of I1, this, the starting of second subarray. In this, you will find the value of I2, the starting of third subarray. In this, you will find the value of I3, the starting of fourth subarray. In this, you will find the value of I4, the starting of your kth subarray or fifth subarray. So in this window only you will find all these values. Tell me, right? This is correct, right? In this window only you will find all these values. Now I can do one thing here. In this window, tell me the minimum elements. Minimum elements are this 2, then again 1 2, then 3, then we have a 4 and 6. I did sorting here. These are the minimum elements that I'm seeing in this window. 2 2, 3 4, 6. Now I need 4. So can I do one thing? Can I directly set these four the as the starting of my four subarrays? These four values. Can I directly select? Yes, I can do that. Is it? It is possible. How it is possible? So let's say this is my second subarray. Let's say this is my third subarray. Let's say this is my fourth subarray. And let's say this is my fifth subarray. See, this is possible. This is possible here. So in this case, this is fixed. This one is fixed. And other values that I'm taking is 2, 3, starting of next is 2 and starting of next is 4. So what is the sum I'm getting here? 2 plus 1, 3, 3 plus 3 is 6, 6, 7, 8, 12 is the sum I'm getting here. 12 is the sum I'm getting here as of now. Okay. Alright. No issues. Now next time, why my second is starting from here? My second, maybe it may start from here also. This is also possible, right? This is also possible. So what I will do here, I will just remove this. Now one thing I have checked, this window I have checked. Now next time what I will do, my previous window was like this was my previous window. Now what I will do, I will just select this window and I am going to move it further here. Now I will check this window. So in this window I have to find out the elements now. Clear this part? In this window I need to find out the values. So now this time I can say my this is, let's say, your one subarray, and now here this is also valid, right? So here it is 6 and minus 2, 6 minus 2 is less than equal to your distance 4. Yeah, it is true, it is valid. Your starting of k subarray can never be this position, can never be this position if it is starting from 2. All right, now that simply means inside this subarray only, inside this window only, I have to find the value of i1, i2, i3 and i4. Okay, so now inside this also, again, if I sort the elements, I will get 2, 3, 4, 6, 9. These are the elements that I'm going to get. Now here, can I again choose? I have to choose 4 now, starting point. So can I choose this 4? Yes, I can. I can form. So let's see how. So this is one subarray. This is one subarray. No, let's not take this. Let's take this as second subarray or third subarray. Take this as your fourth subarray and take this as your fifth subarray. So see, again I'm able to choose. So in this case, this one is fixed again. Now after that 2, this 3 you can see from here, then this 2, then this 6, then 4. So in this case, 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 4 is 16, 16 is what you are getting here. All right, so this is done, this is done. Okay, now next time what will happen? Again, this is done, this is done, this is done, this is done. Okay, next time again your window will move further. This is going to be your window now. Clear? And see, let's check if this is valid. So 7 minus starting of the second subarray is 3. 7 minus 3 is less than equal to 4. Yeah, it is valid. So here simply means this is your one subarray, and in this now you have to find the next values of i2, i3, i4, i5, the starting of i2, i1, i2, i3, i4, the starting of other four subarrays. So in this again, what you will do, you have to sort the values. So you will get 2, 2, 4, 6, 9. Okay, so again you can form this like this 2, this is one you can form, then 4, this is what you can form, this is what you can form, and this is clear now. Here I'm taking this, but this will automatically extend to here na last one, but I'm just showing it for just for representation. This can automatically extend, so but we can take. So in this case also, this is fixed, then 2 6 and 4 2. So in this case, if I write 1 plus 2 plus 6 plus 4 plus 2, so what is the value you are getting? 2 plus 1 3, 3 plus 6 is 9, 9 plus 4 is 13, 13 plus 2 is 15. This is what you are getting. Okay, this is done. Now next time what will happen? Again, let me just erase this. Okay, this is done, this is done, this is done. Next time your window is going to move from here to here, here, this part. Okay, so in this window again, just check 8 minus 4 is less than equal to 4. Yes, true. Now in this case again, find the minimum elements, just sort them. So 2, then 4, then 6, 2 4 6, then 8, then 9, right? So that, but so this is one window, then after that this is one, this is one, or you can take this as one, then this as one, and this as one. Okay, so yeah, 2 4 6 8, 2 4 6 8. Okay, I'm able to take that. So here if I write, so I will say 1 plus 6 plus 4 plus 2 plus 8. So what is the output? I'm getting 8 to 10. 10 plus 4 is 12, 14. 14 plus 6 is 20, 21. So among them, minimum is 12, so 12 is my output. That's it. So this is what you are doing here, right? We have to actually optimize our code now little bit, but this is a brute force, and definitely you can give it a try. So let's see how we can further optimize it. So what I will do here, let's say this same example, I take 1 2 3 2, 1 2 3 2, and 1 2 3 2, and 6 4 9 2 8, 6 4 9 2 8. Now in this also, let's say I want to find out the the minimum sum of, let's say sum of min 3 elements, let's say okay, and let's say this is your window. Okay, let's say, just for example purpose, let's say something like this. Now here what you need to do here, let's give the indexing as well: 0 1 2 3 4 5 6 7 8. So this is your window, this is your window. For very first time, this is your window. Okay, now in this, what you do, create two sets, I can't just take a normal set here. If I take a normal set, so in set we don't have duplicates, right? We have just unique values. So in that case, I will take a three set sorted order. So 1 2, and then next time 2 will not be there, and I will just see 3, let's say. But I don't want this na. I want 2 times here. So I'm taking a reset to maintain the order, but I don't want to consider these two as duplicates. So what I will do here to fix this issue, I will store the index as well. I will store them in the pairs, let's say. So this is 1 0 I have added. Then I'm adding it in sorted order, let's say 2 comma 0 or 2 comma 1 this time index. Then let's say so here 3, so I will add this 3 comma 2. Now next time what will happen here, this is going to come in this window. So I will first see here in this window, this, if you see, this 2 is smaller than this 3. So what I will do, I will just simply remove this. Okay, and I will put it here. So I will just name it as extra, and now just name it as chosen. So I'm just going to remove it. After that, I will add this 2, add 3. Now here, see, this one window is done. So in this, if I have to find out the 3, so here I have to find the min 3. So in this, I am just storing the size of equal to 3 only. I will not store more than 3. Okay, now in this case, the sum is, what is the sum? 1 2 and 2. So 4 5 5 is the sum. Okay, no issues. 5 is the sum, as of now. 5 sum. Okay, no issues. Now next time when your window is going to move, so you will notice one thing here. In your window, this element will be removed and this new element will be added. So now let me move this window. Here, see carefully this window. Moving, 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 keeping it here. Okay, keeping it here. So see, this one is removed and this one is the newly one added. So overall my sum is 5. Overall my sum is 5. In this 5, I have to remove this. I have to remove this. So it is going to become 1 and I have to add this one. Okay, this one 6, right? But here one thing. First, let's say I remove it. I remove this element. So definitely it will go move from here. I have completely discarded this element. It will not go to extra. Now tell me, next time when this 6 comma 4 is going to come, is it going to come to at this position? Tell me. So now you are going to say, see here, you will say that answer is going to be sum of minimum 3 elements. 6 plus 2 is 8, 8 plus 2 is 10. But you are wrong here, because in this window the sum is this. So that is why I am taking this extra. So what I will do, before adding this 6 4 here, I will see if my extra is not empty. So from this I will choose the whatever the minimum value that I have here in the extra. In extra also I will maintain the sorting order. Okay, so what if there is some value here, so I will just move it to this here at this particular position. Okay, at this particular position I will move it. That's it. And then after that I will add 6 comma 4 here. And now in this window, if you see, instead of 5 minus 1 definitely we have to do, but 6 I'm not able to move to this position, but I'm move it to extra. So 6 minus 6, and I move 3 to this place. So now this cancel out. So 5 minus 1 is 4, 4 plus 3 is 7. So 7 is output. 3 plus 2 5 7. That's it. That's it. Okay, next time again your window is going to move. Now you will see that this element is going to be removed and this is going to be added one. So first let's move this window. Okay, your window goes here. Okay, done. Remove this 2 comma 1. So you have to remove this 2 comma 1. So now overall sum last case was 7. So 7 minus 2 you did. Okay, you have added a new elements, that is nothing but 4. So plus 4 here, and definitely the 4 is going to come to this position, 4 comma 5. So here 7 minus 2 is 5 plus 4 9. So 9 is sum, and here I'm not checking now actually. 4 5 6 7 8 9. So from here directly I'm doing the calculation in one go. I'm not iterating over all these elements again and again. So as I am moving, I am removing that element. Then whatever the new element, I'm going to add that, let's say here. And if that element doesn't fit here, but here it comes, so I have to subtract that again element, and whatever the element that I am moving from here, so I have to add it. So this is the flow actually I have to maintain. So what I will do, I will, let's say first I remove one element, then I will see extra, if extra is moving upward, so move that extra to upward. So add that element, maybe you can try like this, and next time see if new element inserted can fit here or here. So if it is able to fit here, then from here we have to remove the max element to here, then we have to subtract that. So somehow like this I will maintain my calculation. So this is what I have to do to optimize this code further. Okay, and everything else will be same only, right? So let's write the code and see what we are doing. Okay, so easy only, nothing very difficult. Now whatever I explained, I will just do the same thing. Okay, so here int n is equal to nums dot length, and now we have to, let's create the tree sets now. In this tree sets, what we will keep, we keep the smallest k minus 1 values. Smallest k minus 1 I'm saying because we know one value already, that is the starting of my array. First sub array is always starting from 1, first index only, 0 index only, right? So k minus 1 values in current window. So here what I will do, I will just create one tree set, and here I will take just int. I will add the pairs now, that's why I'm taking like this. And here I will say chosen, and new tree set. And in new tree set, right, we are adding these pairs now. So let's say we have two pairs, a comma b. So how I'm going to do the sorting? So I will first check if their first value is not same now. So in that case, if a of 0 is not equal to b of 0, so first value is not same, then just sort based on the very first value. Okay, return a of 0 minus b of 0. But if their first value itself is same, then we have to sort them based on the indexing. So I will say return a of 1 minus b of 1. So this is what I have to do here. Now after that, here we are keeping the smallest k minus 1 values in the current window, and I will create one more tree set where I will going to keep remaining values in window, because remaining values are also useful, I have shown you. So what I will do here, I will just simply copy this, I will paste it here to save some time, and here I will just write extra, and everything else it will remain same here, same thing. Now after that, what I need to do here, let's take long. Okay, because some values are going to very big. Here let's take it 0, and long best is equal to long dot max underscore value, and here index, let's take it to equal to 1. Now initial window is going to be start from 1 to, and it will be distance plus 1, right? This is going to be the size. So here if you see distance 4, so what is the size here? 1 2 3 4 5, 5 is the size. Okay, so this initial window is going to start from here to 5 size now, 1 2 3 4 5 here until here, right? Clear? This is the first window that we took. So this initial setup I will do for the initial window. So here I will say y, and it is starting from index 1, so that's why I'm keeping here. So I will say here, while my index is less than n, and I will also say index minus distance, it should be less than 1. Okay, now inside this I will first take the pair, right? So here let's say int p is equal to new int, and here I will add nums at this index value, and here I will just add idx index. Now after that, what I will do, first I will move it to chosen. So here I will say chosen dot add p, and my cursor I will update. Okay, so my cursor is going to be cursor is equal to cursor plus nums at index value, so this value. So I will just paste it here. This is done. And if chosen dot size, if it becomes greater than k minus 1, because we have already fixed one element in the starting. So here in this case we have to move this element. So move is equal to nothing but, you can say chosen dot poll last. So this is just a story that I'm doing, whatever I explained na? And if you are moving it to the chosen, right, so in that case you have to subtract the sum from chosen. So here from the cursor, so you will say cursor is equal to cursor minus move at 0. Clear? And here you will say extra in extra you have to add what this move. So this is done here, very basic setup. And this is a while loop now, and here you have to do this idx plus plus every time. So that's it, this is what you need to write here inside this. Now we will slide the window. That's it, first window is prepared, ready. Now we have to just slide the window. So here what I will do, again I will just copy this and I will write while index is less than n. And here inside this I will say again int p is equal to, I will just simply copy this, int p is equal to new int nums index, okay, this one. And chosen dot add is equal to p, my index is already incremented here, remember, right? And here chosen dot add p this, and then after that cursum I will add this nums, okay. And after that if chosen dot size becomes greater than k minus 1, then I have to move this, okay. So I will just do this, copy this and paste here, same thing. If chosen dot size becomes greater than k minus 1, okay, I'm moving it. Then I have to store the best answer here, so whatever the best answer, okay. So best is equal to I will say math dot min of the best value and cursum value, right? So best I'm taking here, okay. So initially it is long dot max underscore value, so I am taking the best as min here. Done, updated. Now we have to remove the element going out of range. Remove element going out of range. So here int out, let's say, okay, and I will say idx minus distance. So when my, this is one window, right? When my idx is moving to this, so the element is going to be removed is nothing but this idx 6 minus distance. If I do 6 minus 4 is 2, so definitely uh what element I'm going to remove, so it is going to be 2, okay. So I hope that this part is clear why I'm writing this. So int out is equal to index minus distance. So here this is one window, right? This is one window. Next time when I am moving to this, okay, so here what I will do, 5 minus, if I do a 4, so that simply means 5 minus 4 I will do, I will get 1, so that simply means 1 is the element that I am going to remove now, okay. Next time again from 6, right, 6 from 6 I am moving further, so in that case I am going to remove this 2 and then I will move here like this, okay. So this is what I'm writing here, out is equal to index minus distance, then int remaining, okay. So here you can simply copy this, and here let's say int, let's say this is rem, okay. And new int here nums of out, we are removing this now, out, and here this is out index, out index, okay. Now after that I will say if chosen dot remove rem, okay, this, if from here I am removing, then in that case this c should be small. In that case what I will do, cursum I will update as cursum minus nums of out, okay. So cursum I will just simply update it as minus equal to nums of out, and I will check if first I am removing, okay, then I will check if extra is not empty, then from there I will pick the element na first. If extra is not empty, then from here I will take, so I will say int take the element, first element I will have to take na from extra dot poll first element, let's say I take, then I have to add this to chosen dot add take, then then once I add it, then definitely I have to update the cursum. So cursum is nothing but, you can say cursum is equal to cursum plus take of 0, right? This is done. So this is what you are doing here, and here your if condition ends. So from if from chosen you are removing, else from extra you have to remove extra dot remove the rem. Okay, and here you have to just simply do idx plus plus, that's it. And here in the end you have to just simply return, first is the value at nums of 0, that is always fixed, and the best answer that you are getting from of, that's it. So this is your code. Now let's run it. So now let's fix it. So int, let's run it again. So see, all the test cases are accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.